Hello, everybody, and good afternoon, evening, or morning, depending on where you are. I've had several folks ask me to do a series of casual video recordings on some of the topics that I discuss on LinkedIn. I'm going to do this all at one shot, no video editing, so we'll see how it goes. It won't be perfect, but hopefully there'll be some good information for you. Today's presentation is around identifying business opportunities in the challenges that are facing tier ones and OEMs. And for those of you that aren't familiar, tier one and OEM is really a designation we give to either automotive manufacturers, which we call OEMs, or tier ones, which are the immediate suppliers to those folks. I'll give you a little bit of a context here. Just for a background on me, I'm an automotive and mobility strategist. I've been doing enterprise architecture for decades, worked for some of the top consulting companies, and I have a lot of experience in the automotive, industrial, manufacturing space, as well as some other verticals. I am an avid motorcycle enthusiast. Spent 2 weeks traveling Ecuador last year on motorcycle with a friend, and I am also a farmer. And so you will frequently see pictures of me with my turkeys or other animals hanging out on the farm. I am an environmentalist for sure. And so I like to bring together all these loves to deliver things which are impactful for businesses and help the environment as well. So the automotive industry is facing some pretty interesting challenges right now. And again, I'd like to say that they are also, opportunities. Every challenge is an opportunity to me. So I'm just going to go through these, and I will be, over the next few weeks, breaking these down in quite a bit of detail and talking about specific solutions that address each one of these different areas. So I'm just going to go through them briefly for the moment and see if any of these things resonate with you or you're experiencing them yourself. So firstly, the automotive ecosystem is highly fragmented right now, and it is seriously worsening by the day. And this is really a result of a switch from the mechanical world to the digital world. And as you move from a mechanical to digital, you really lower the barrier for people to get into the business. So folks that normally would have had to bring out a lathe and have manufacturing expertise and be able to manufacture electronics to make things work, they don't have to do that anymore. A lot of these things that are being developed nowadays are either prepackaged, subcomponents that can be integrated into a vehicle, or it's software that's being developed which controls and manages all of these things. So we are in a very highly fragmented environment. Additionally, there are a lot of companies that are actually vying for this business. And so the solutions are all over the place. They provide different opportunities to these companies, but also a lot of confusion. The software development, which I just mentioned, that is around all of this has moved to a very globally distributed model. Whereas before we developed solid software on site for very specific systems, it's not happening anymore. And the people and the tech that are required to do this are spread all over the world. They're constantly in flux, moving from company to company, and the code needs to be really put into a pipeline and managed effectively. It's not happening right now. So we're still seeing a lot of duplicative effort. We're seeing software being developed 10 different times for 10 different systems. It's just not working. And it's really putting a huge drag on the ability of these companies, especially OEMs, to move forward in defining their software-based vehicles and EVs and things that kind of flow into that. We also know, and I think this is not just in the automotive industry, but very important in the automotive industry, that fully articulated digital twins are critical in order to develop these software-defined vehicles. So in essence, whereas before we would mock up a vehicle from different parts and pieces and build it out, tying everything together, making sure it worked, we don't really have to do that anymore in moving into the next few years or next decade. We'll actually be modeling vehicles completely in the cloud space, really in a software-based fashion. And we'll have to work to integrate software seamlessly across different vendors, different development systems. And we need the ability to take physical devices. Say you're building a power system for a vehicle. We need the ability to take that and digitize it, bring it into the development environment, and place it into a digital vehicle. Essentially be able to model all of that and make sure it works before we actually go to build something. So the fully articulated digital twin is critical. I would say that right now we're dealing in parts and pieces of this, but the holy grail is to get to a full vehicle. Now, again, feeding into the software piece of this, the application and OS tooling is not end-to-end, which really complicates this whole situation and makes everything extremely complex to put together and manage when you start dealing with testing and variations in the code itself. So the tooling, I would say, is probably 2 to 3 years behind where it needs to be. We're also doing a lot of development in, I'll call them ancient systems that are around 5, 10, 15 years or more. There really needs to be an entire shift there in the way we code, and I'll discuss that in more detail. Now, unless you've been under a rock, you know that electrification is dominating the automotive landscape. The OEMs are pushing to deliver millions of EVs in response to fuel prices, regulation, green initiative, you name it, whatever's floating around out there right now that's forcing that move. Also, some companies just see it as a smart business move at this point in time. Now, not to overshadow the fact that there are folks doing hydrogen development, hybrid vehicles, whatever, but EV is definitely a dominant factor here. And EV specifically requires a software-defined vehicle mindset to make it work properly and be able to update it and iterate it and keep developing better products. Well, that's going to continue. It's not abating anytime soon. Silicon shortages are still plaguing the OEMs and the partners. I've heard some companies say that, we're not having problems. I've heard others say, I can't get chips. There are boards that are being developed very rapidly and brought to market, which people just can't get a hold of. And there is a desire to run faster than has been in the past. And so the silicon shortages are a big deal. And speaking back to my point on digital twins, we have to be able to model all of that stuff in software and additionally integrate hardware components into that software development model and be able to have them work together as if they exist in one seamless device. So that's going to continue to be a problem. I don't see it abating anytime soon. We know that foundries are being, basically built in the United States right now and other countries to get around some of the supply chain issues, but I don't see it going away. Now, this is a very important point. OEMs and Tier 1s, in my mind, based on several conversations I've had, are fighting a two-front battle. One, they're trying to build the development environments to do all of this, right? So all the edge development environment, the CI/CD pipelines, the non-siloed development, systems around the globe. And they are having trouble with this because the OEMs and the Tier 1s are not software companies. They'd like to become software companies, but they're not. And companies that have been dealing with this for years in the tech space already have this problem licked. And if you look at its application within the automotive space, it's really a matter of adaptation. So companies that are trying to do this themselves, I would caution them not to at this point in time, because if they do, they will take away from their efforts to build the actual software that makes things go. So the software that goes in the vehicle is just as important as the software that enables the building of it, the environment. So they're fighting two battles and they're losing. A lot of companies are falling way behind in their timelines. They're getting 3, 4, 5 years behind, and that's a serious problem. The last time I've gone on here is really around monetization, and the path to monetization is unclear. And organizations are trying to make decisions right now, which could make or break their revenue models for the next, decade or so. And you may have seen all the brouhaha around BMW wanting to charge customers for heated seats, right? When the heated seats elements are already in the car. That's an example of monetization, which really doesn't make any sense. There are also a lot of companies talking about the monetization of the data. And yes, there is a huge opportunity there, but you've got to know what you're monetizing, why you're monetizing it, and who's going to pay for it. So these are all challenges, again, but opportunities. So one of the things that I've told a lot of the OEMs and Tier 1s is that they are at a critical inflection point and they've got to take action. They can't just sit and keep waiting. I put this grid together. It's simple, but I think it's powerful. If you look on the left-hand side of the graph, we have a line here for development time. And in the traditional production environment, building ICE type vehicles, internal combustion, doing embedded and static code, development times have been pretty long, a pretty long tail on that type of stuff. And the revenue volatility around that has been very low because you've got a 3 to 4 to 5 year pipeline, if not longer. You're developing your code, you've got time to test. Your revenue is pretty guaranteed if you can get the vehicle out the door. And lastly, there's really not a lot of rate of change or complexity. It's a fairly simple proposition. And I'm not saying that building a vehicle is simple. It's not. It's very complicated, but it moves at a much slower pace. As we progress into software-defined vehicle production, now these things all kick up. Your development time needs to be faster. Your revenue volatility gets huge because you now are facing competition from other companies that are upstarts in this space. You may be, if you're a traditional OEM, you're dealing with Tesla right now, right? That's the elephant in the room. You're trying to move beyond that. So your revenue volatility can be very high, and the rate of change and complexity is tremendous. So I think this is a simple graph, but it conveys something very powerful that you've got to take some action. And what I've done is some folks have asked me, what's the path? And I just laid it out here very simply, a 3-step path. There's a lot of more detail to this, but we can start here. The first thing you have to do is an architectural definition around your software-defined vehicle. What's the back end going to look like where you're developing? What's the in-vehicle piece going to look like? What actually rolls around on the streets? And how's the consumer going to interact with it? You've got to nail these elements down before you start developing anything. Now, the platform implementation itself will take some time. This is part of that two-front battle. You've got to implement a software-defined vehicle development platform where you can actually develop your software and deliver your software in a continuous fashion to vehicles on the road, get feedback, bring it back into that cycle, and then redevelop your software. This is not, and I repeat, this is not OTA. You develop software, drop it to the vehicle, it runs. This is a real living, breathing, real-time cycle. And then lastly, once you have these mechanisms in place, you've got to identify the ways in which you're going to monetize. The first two things are kind of a given if you're in the business, right? It's not whether you can or cannot do those things. You have to do those things. But you do have to figure out how you're going to monetize. What can you charge for a vehicle? Can you sell the subsystems? Can you just develop the software and sell that? Can you monetize the data, right? What is it that you're going to do? You may even choose to do that first. I don't know. But it is something that has to happen before you move into production. So before you do anything, make sure you've done these steps, essentially. So in the SDV space, it's definitely about the partnerships. And I've tried to break this down into, the reality of the situation, the opportunity, and some of the required actions around it. So I'm going to say this, and if anybody tells you differently, I'm going to say they're lying. The SDV ecosystem cannot be delivered by any one company. It is too complex. There are too many pieces. There's a ton of integration work. The roadmaps are all over the place. And there are a lot of specialized companies in the space. So that is a challenge. However, now is the time to compare holistic software-defined vehicle solutions that are being offered by the leading vendors. They're out there. People are doing that. They're saying, we're going to give you an entire ecosystem that lets you build a car from the development phase all the way through the operations phase, dealing with the back end and the in-vehicle software, and then dealing with the customer as well. Those opportunities are there. So you've got some actions on this one, right? You need to research who are the thought leaders out there. You need to map those software-defined vehicle components, right, across people, process, and technology in your existing organization. You've got to meet with targeted tech players. So there are folks that are specializing in AI, or they're dealing with vehicle security, which is going to be a big area. They're dealing with simulation and building these models, or really they're just focused on providing a development environment for all of this. So you've got to meet with those folks as well. And as the old architect in me will tell you, you have to assemble the initial architectural teams right now to start dealing with this. And I recommend you pull people from your enterprise architecture and solutions architecture teams and let them start melding into what you're doing in the automotive space, if that's where you're working. Now, there are several working groups like SOFI, Eclipse, Cobisa that are developing standards for development, for the microservices architecture, for the in-vehicle signaling, et cetera. But there are really no consumable commercial standards that have emerged yet. yes, there are people that will tell you that the standards are there and they need to be adopted, and yeah, it's good. But there are several competing standards that are being developed. And that's okay, because right now we're in a discovery phase. And so it's a very good idea, if you're in this industry, to join some of those working groups, understand what they're doing, participate, contribute, and be part of that. And these working groups are going to allow for a very rapid exchange of ideas, and they'll do it in very focused areas. So you might have a very specific area that you care about, like ADAS, and there'll be folks working on ADAS, and you'll be able to share ideas in that space and accelerate what you're doing. So what I recommend you do is identify the working groups that align with software-defined vehicle objectives, right? So if it's SOAFEE and you're doing ARM-based microservices architecture, that's a great one. Select, and support internal software-defined vehicle thought leadership champions within your organization. People that are out there saying, what can I do? What is the art of the possible? These are the people that you need to support. If you don't, your products and your future generation of vehicles and products around the vehicles will go nowhere, I guarantee it. And then there's a great opportunity to sponsor some of this industry-specific development and actually feedback into it. I'm a huge open source proponent, so the opportunity to bring stuff that you develop back into the channels and share with others and get things back out of that are really great. You also need to you have to look at very specific technology and expertise that needs to be integrated, because there are whole stack solutions that are being developed right now. But once again, I don't think that everybody has every answer that you need. Of course, though, there are certain companies that have a heritage in automotive. You're going to want to be working with them because they understand this full stack. And then there are other companies that come, say, for the communication space that are kind of working backwards in the automotive stack. So you'll need to figure out, what's happening there. You will need to establish very strong digital transformation teams to do some of the stuff I'm talking about here. And you'll need them to drive internal integration initiatives. And really, at the end of the day, turn the expertise, things that they learn, into revenue producing type activities to pay for themselves. So from a required action standpoint, you need to identify non-core technologies that need to be integrated into these solution stacks. You need to establish and build out your digital transformation office and make sure you've got extensive project management capabilities, because you will be needing them. And then really go explore these client-facing digital transformation opportunities, because just developing a vehicle or a system for a vehicle doesn't do anything for people unless it helps them with their business problem, the thing that they're facing. Think about it like this. You develop a truck for somebody who is a carpenter. The truck is an enabling tool. It helps them do something. And if you develop an electrical truck, which has the ability for them to plug in a saw or to run other components, right? Now you're solving a business problem for them. So these digital transformation opportunities need to be understood. The last thing on this list is that the march to software-defined vehicle should not be about reinventing the wheel, but adapting it. As I mentioned earlier, there are tried and true enterprise edge computing technology, software development processes that can be leveraged against these automotive challenges. And yes, I recognize they are unique challenges, but they're not that unique. Say 30% of 100% is unique. The other 70% is plain vanilla stuff that we've been dealing with for 10 or 20 years. You can transition it over. So you've got to really leverage the existing investments against these very specific problems so that you can deliver on ROI. Otherwise, you'll be spending a lot of money to do something that is already been done, and then you're not going to get your money back on the investment. So think about that as well. I recommend at the end of the day that you document existing technology that you can leverage against SDV, identify where the gaps are, speak to partners about filling those gaps, both yours and theirs, and then build on existing differentiated technology, stuff that's already there. Again, don't reinvent the wheel, just adapt it. So I've also included some examples of monetization here, some short through long-term. I recommend, if you're doing monetization, that you break it down, things you can do now, things you can do in 6 months, things you can do in a year, right? Things you can do in 2 years. And there are definitely some now opportunities. So for example, in this space here, develop plug and play energy transition software that can bridge ICE and alternative energy power plants, right? optimizing existing mechanical systems and establishing frameworks required for next generation SDV. It's a lot of words, right? But the idea here is that you can create an energy transition middleware that sits in a vehicle that will work in a hybrid environment between the mechanical and the electrical resources, right? That's a monetization opportunity. You can do things around alternative energy management, being able to actually help people manage power. It's not just a vehicle thing. You see people taking their vehicles and plugging them back into the grid and providing power back into the grid when they're not using the vehicle. So there's a lot of energy management stuff that has to go on. And you can build frameworks, again, for doing software-defined vehicle that could be monetized by your company or others. And I'm not going to get into this. I'm going to actually do a significant presentation on monetization. But I just want you to understand that there are opportunities to get into to monetize, but you've got to work through them with a business mindset. Don't think tech, think business, and work backwards into the tech. The other thing I would encourage you to do is watch some of the technology trends. And in this case, since I come from a background across multiple verticals, I've also been involved in Industry 4.0 type use cases. There are a number that you can be looking at. If you look at this wheel here on the right-hand side of the screen, these are a number of things that are happening right now in Industry 4.0 space that are readily adaptable into automotive. So to my point earlier, there are people that are already solving for a lot of these problems. As an example, if you look at this item, blockchain and distributed security, a lot of the software that's going to go into a vehicle is going to need to be verified and validated before you pump it into a vehicle and could cause somebody to drive off a cliff, right? So blockchain validation of the software itself is a possibility. People are already working on it in the crypto space. They're working on it in NFT space. It can be leveraged here as well. I recently spoke with a upstart automotive company that is using, again, blockchain to develop NFTs for contracts, right? You want to have a vehicle built, you get a contract, you pay for that contract is assignable. There's a lot of stuff going on here that can be adapted. There's also a huge opportunity to extend your core offerings into the green space. We don't go a day doesn't go by where we're not hearing about, save the planet, go green, climate emergency, right? All that stuff. If there's an opportunity for you to take what you're doing and extend it into that space, not only do you get good publicity out of it, but you're also going to get good opportunity to, build more sustainable systems. You have a new revenue source that you could be looking at in the next few years. For example, GM's doing this now around power management, power generation, some of the things we talked about. You'll see their ads out there. You can also be first to market with an industry-specific software-defined call it vehicle transport, whatever you want to call it, ecosystem that addresses a very specific business need. So we have the same need to develop software-defined platforms for agriculture, for mining, for rail, for energy, right? And there's an opportunity to create marketplaces that go with that and then monetize those marketplaces. And then lastly, again, be looking at this wheel of capabilities because there's an opportunity to make strategic investments in companies that closely align with your strategic pursuits. In that case, buy versus build when it makes sense, right? Or partner with them. So take a look at this. I will get into this in more detail in the coming weeks. Each one of these slides that I'm going over right now, I'm just intending to give you an overview, but I will dive into each one and spend some significant time if everybody finds this useful on each one of those tracks. So before I leave you, I want you to keep a few things in mind from an execution challenge perspective in the software-defined vehicle space. Number one, functional safety and compliance. Vehicles have to be safe. They're not cell phones. When your cell phone goes belly up, it reboots, you're okay, you're probably not going to die. If a vehicle has a big problem, it could run off a cliff, as I mentioned earlier. So we've got to really be looking at functional safety in the vehicle. We have to keep an eye towards that. However, I would caution about letting that rule every decision that you make, because there are ways to develop software and then go back and ensure that the safety is there. Also, there's a lot of discussion around Linux. People want to leverage Linux versus real-time operating systems that are a little more determinate. And really the argument around that is around continual certification of those Linux systems. So that stuff's coming. There are companies that are doing that right now. You're also going to need an edge delivery infrastructure. I've talked about that several times. The ability to develop, deliver, and operate in a continuous cycle, what I call an infinite software development cycle. You got to have the edge delivery infrastructure. But again, don't try to build that, try to adopt that or work with a company that's doing that right now. If you try to do that and develop the software in the vehicle, you're in trouble. Keep this in mind. Silicon and OS rationalization is also a big deal. I mentioned earlier about silicon shortage, and yes, that's an issue. But a lot of folks are coming into the automotive industry from other industries, right? Other computing industries. And they're saying, why in the heck are there 20 different operating systems, 20 different processors? Why can't we get this down to one or two or three or four, whatever it is, right? So there's a huge opportunity around silicon and OS rationalization, but I believe that it's a very daunting task. And we want to run fast, but maybe we have to do, kind of a crawl, walk, run approach here. Containerization is going to play a huge role here. Things you think about, Kubernetes, and abstraction of the software and hardware really not where it's not as important what's underlying, right? Like we have in the data center right now. It's very important to keep in mind that the OEMs are always worried about being locked in. Any company you talk to does not want to be locked into a specific vendor or a specific system. I think that they're going to have to get over some of that fear. And the way they do that is by selecting vendors which propose open and extensible systems that allow them to still maintain ownership over what they develop, be able to integrate existing systems, be able to enhance and make better what's there. I think that's going to be the way we belay the fears in OEM lock-in. And then this last one is a really big deal. I think there is a huge skills mismatch going on right now. Companies are laying off tons and tons of people that have traditional automotive knowledge. And I get it. You have to do that because you need the resources to hire people like software engineers, people like me that do enterprise architecture. I get it. But be careful who you're throwing out the door because you may have to go hire them back in a couple of years. It may make sense to retrain those people, to teach them about software development, to integrate their ideas into what you're currently doing and work in parallel. And I know for a fact that we're not going to find all the people we need. If we're working in the United States, it's going to be folks from India, it's going to be folks from Latin America, it's going to be folks from Europe. They're all over the place. Going back to my point of needing some of the edge delivery and development infrastructure that's global and collaborative in nature, you're going to have to do it. So that's all I have today. Just a brief summary of some of the things that I've been talking about with folks. And I'm going to go into great detail on each one of these if everybody finds this of value. If not, we'll just stop it here and go off and do other things. Let me know, give me some comments, some feedback on what you think. Thanks.